Hello and welcome to everyone here in the audience, but also behind the screens across the globe. It is truly an honor to be the moderator of next session, the panel about data exchange in the space domain. As I was introduced, my name is Marily Hendrikson and I work at the Ministry of Economics and Communications, where I am leading the AI and cybersecurity topics. Please allow me to elaborate a bit why I am the person standing here and not anyone else, so that let's establish a bit of a trust level. My background. I'm combining now the two or three keywords that are very inherent to the following panel. These are data, cybersecurity, and space. Before working at the ministry, where I started just in the end of November, I was a cybersecurity project lead at Startup Estonia, where my aim was to strengthen the cybersecurity startup ecosystem. I was there for 4 years and I experienced really a lot. It happened during the time when our startup sector was booming. For the 4 years in a row, the sector grew 30%, 3 and 0% in a year. That, of course, had an influence also on cybersecurity sector developments. So this is the background from the cybersecurity. The latest great news from the field is that Estonia has received its 9th unicorn company, and it is the first in the field of cybersecurity, VERIF. This is something that makes us Estonians really, really proud. I cannot say that this is work of mine, but it is a piece of the best example within our ecosystem. I'm a strong believer into data economy and the power of data and creating new values with it. The change that I made work-wise and working now for the ministry, I feel that I have a mission. And the mission has 3 components. The first one is to enhance the research, development, and innovation maturity of Estonian companies, to enhance in parallel digitalization and cybersecurity capability of our companies. And the third one is to strengthen the cybersecurity sector itself. It's all about our economy, it's all about creating high-value jobs, and it is all about high-tech opportunities. Starting from this year, I'm happy to be also part as an Estonian delegate at different European Space Agency boards. So, herewith, I hope that I have given you some glimpse of why the following topic, data exchange in the space domain, is the topic that we should be speaking of. I have the utmost pleasure to invite our guests. Please come on a stage, Dr. Srinivas Setty, Kaarel Hanson from Guardtime, please have a seat, and Stefano Alberico. So, please find your seats. Ups.
Thank you.
Thank you for being here with us, and also for the previous panel where Srinivas had a chance to give us some kind of glimpse what is happening in the data landscape and in space, but that was not the topic in a previous session. So, the aim for our panel today is to specify the linkages and bottlenecks between moving data between different space assets, cybersecurity, space, and what is current situation and what the future will hold. Today we are lucky, we have 3 representatives. They cover both upstream and downstream. The experience package is quite broad. All of them have a background in cybersecurity, so really eager to learn about what you are doing and what is your organization's contact point to the data exchange landscape. We shall start with Srinivas. Yes, please.
Sure. Thanks again for having me here. It's a great pleasure and have these discussions. In the past panel, as you mentioned, we were discussing more broadly on space traffic management. Data exchange is one of the core necessity for having the space traffic management itself. So when I'm talking about the data exchange, so I'll stick to my domain of expertise in the context of space situational awareness and space traffic management. What we are doing in this regard is that we are trying to tackle different needs in this sector. So as I mentioned in the past discussion, so there are 3 main pillars. One is data generation and the processing entity, and then providing services out of this one. And the links between these 3 are where the exchange is still not fluid enough, and the technology is still hindering to perform it in a trusted and credible manner. One of the activities where we are engaging in is basically we have the customers who are satellite operators and owners, and they want to track their satellite. So we try to coordinate with the sensor operators and owners. So we get the request from satellite operators and owners, so this is the thing. So we do the processing to say that on this day, this particular time, so please point your telescope in this direction. So we get the data, process it, and then give it back. While doing this thing, so sensors do not want to disclose their capability, whether it's radar sensor or optical sensor. So you have to remove the certain information content out of it. And while we are providing the orbital information to the sensors, the satellite operators and owners, they do not want to share the information relating to their spacecraft in detail. So what kind of object? You don't want to identify it. They just want to know where exactly it is. So this is the challenge we are trying to overcome as well, that how to deal with it. If we are putting these stakeholders together, and how can they exchange the information without not having their needs sacrificed on either side? Yeah.
All right, thank you. Let's go further with Kaarel.
Yes, hi. It's a pleasure to be here. First and foremost, Guardtime is not a space company like GMV. So our space heritage is far more shorter, but we have initiatives in the space domain as well. But maybe giving a broad or brief overview of what we do in the cybersecurity domain is we are a deep tech company specializing in building cybersecurity and complex data management solutions. Our company was founded with a mission to make the world's information universally reliable, and we can do this by we aim to do this by replacing the human trust with digital truth, with the mathematical proof of correctness of any kind of information. It can be any data, files, even Earth observation images, processes. And when we talk about processes, then this can be supply chain, logistics, and so on. We can validate and verify each, let's say, event in the process and validate whether something happened or something even didn't happen in order to reveal any errors that have happened during the process, either by deliberate or accidental, either by deliberately or accidentally. We are a blockchain company, or we don't advocate ourselves anymore as a blockchain company, but we have a widely accredited blockchain solution called KSI, which is proven to be one of the world's most scalable and efficient solutions, which we have developed together and for governments and enterprises. And the good thing with, let's say, cybersecurity business is that it's not limited to any specific, let's say, service, specific industry, specific sector. And we can apply our technology to a variety of sectors, industries, and for a wide range of use cases as well. Maybe some things not currently we are working in the space domain, but in other domains is that we have implemented a solution, a very truly scalable solution for digital currencies. End-to-end pharmaceutical value chain management. And also we're working on data asset tokenization. And when we talk about space, our space endeavors, our space journey started roughly 5 years ago, when we discovered a market gap in the verification and assurance of Earth observation, or the integrity of Earth observation imagery. And today we have a working prototype called EOGuard that assures the integrity of Earth observation imagery. And this is currently operated in ESA as well, and we have some other plans as well. But it does not need to be limited to only Earth observation imagery or Copernicus imagery, let's say. We have done some studies in the area of how can we apply distributed ledger technologies and blockchain technologies in the space domain. And one of the areas that we discovered was, and is the space or satellite surveillance and tracking, which Srinivas is expert in. And we have found a fit there, at least, well, we're working towards it, to support trusted and reliable data exchange in the satellite surveillance and tracking coordination network. And finally, this is an area that we are not actively exploring yet. But we have done some work in that, but not in the area of space, which is quantum-resistant techniques or technologies. And there will be quantum computers, generic, or let's say, generic quantum computers that will most probably make current encryption algorithms vulnerable. And well, post-quantum area will arrive, and we aim to do some research in that area as well, in the space domain.
Thank you. Very good. Stefano.
Okay, so thank you again for inviting me here to be here today. Regarding, you mentioned data exchange, and then you say the keyword also upstream and downstream. So we are actually, with my company, with Skudo, we are focusing basically exactly in this domain, and specifically on the protection, actually, of data exchange. So whatever is the direction, so uplink or downlink. And we have been working on, let's say, two main pillars. One is doing some hardware, let's say, based encryption. So to do data protection, basically, we are dealing with the cryptography functionality. So our approach has been to try to strive for the, let's say, highest level of security. So you can't reach actually 100%. You always try to get the maximum you can for, let's say, the given kind of application. So we have been using hardware encryption to provide a sort of base ground foundation and build the so-called root of trust. So a fundamental element that allow you to build your cybersecurity solution. And then we have been working the second aspect pillar a lot with data protocol and an application, because at the end, whatever technology, let's say, you develop, the one of the challenges also exactly integrating, for example, for space application. Now, data exchange in space application, of course, is a key. So you want to, like I mentioned, you have a lot of data that needs to be traveled up and down, but you need at least to, make sure that those data are protected. And so to let's say, provide some sort of protection, you have to work a lot with standards and data protocol that are available for space. And in space, I would say it's a challenge. Let's say, compared to on Earth, probably most of these problems are solved, let's say, at least in this kind of domain. We have a lot of experience. and many, again, a lot of experience. So we can look back and see, and we keep improving. But in space, it's really, we're probably at the beginning. Cybersecurity is probably still a bit of a buzzword. A lot of people say we need cybersecurity, but then in practice it's probably one of the last things. So they, spend a lot of money and energy to build the system, and so there is still a lot of work to do to, make it really mainstream. Maybe we will touch more in the
Yes, absolutely.
questions.
Thank you. As said earlier, then software is defining space. Yesterday, we had discussions also that if you ask from any space operator, are your systems safe? The answer is yes. If you ask, would you like to be pen tested against your systems? The answer would be, wait a while, we will come back to you. So there's never 100% security, not in real life, not in physical life, never. We are experiencing the rapid change.
That's why we need insurances, right?
And it doesn't work either always. But so it used to be for space domain that it is okay when the safe systems are secure by 60 to 70%. What is the current percentage that should be acceptable? And whether it is different in some cases, upstream, downstream. What are your insights about this? Srinivas.
Yeah, thanks. So the regulation from the space race era, when the first satellites were launched in the decade of 60s, at that time, the NASA and JPL adapted the regulation saying that your satellite has to be 65% reliable. This is in the context of operations of the satellite itself, and this was the same reliability that they adapted for human space flight, which is kind of scary. This worked in the physical sense in the past, where they had very few spacecraft launched every year. But nowadays we have, just this year alone, SpaceX has launched over 1,400, 500 satellites. So if we go with statistical reliability and probability of failure, then we are going to lose 350 satellites. No, that's not acceptable. So definitely this has to be changed. I'm not sure that if the regulation has adapted the wording to increase the reliability. But when it comes to communication and data exchange, this reliability has to be much higher than the structural reliability itself. So where you have to have the chance of failure 1 in 1,000 or 1 in 10,000. So that should be the order of magnitude for the reliability in data communications, because any misinterpretation can lead to more disastrous structural failures is for kind of certain that it's going to happen, but in data it could be more dangerous, leading to further decision making based on this data as well. So in this regard, the data reliability has to be much stronger, 99.999. Yeah.
Thank you. Other ideas, Kaarel?
I think it's I think it's a bit of a slippery road to take, at least from the cybersecurity point of view. So I think I need to put two different hats here. So first of all, when I put on my space professional hat, then yeah, sure, certainly satellites have flown successfully for decades, and yeah, we can't assure that it's always 100% secure. 100% reliable, just as Srinivas mentioned. But we really need to account for all the risks that we can manage. So there needs to be mitigation plans for every, there are certain levels of risks, but we need to have mitigation plans at least for each of them. Well, this is my space professional view. Well, it's all working now, but it could drastically change in the near future. Now, when I put my cybersecurity professional hats on, then I would say none. There is no acceptable risk. But still, when we get to when we talk about what you mentioned, Marily, as well, that if you ask a satellite operator, is your system working properly, or is your system secure 100%? He would say yes. For example, we have our main services have been running flawlessly for the last 10 years. More than 10 years, we have never had any incidents. But if any customer would come to us and ask, so can you guarantee us that your service is 100% secure? We will not tell that because we don't know the unknowns. We know the unknown. We can mitigate the known unknowns, but we can't know the unknowns. We work with the unknown unknowns. That is sort of the loophole, which word I don't really like as a cybersecurity professional.
Right. Very good. Stefano.
Yeah, interesting actually points. Just made me think when you mentioned, Srinivas. So probably many years ago, you say acceptance level was probably 65%. And then I would say maybe just first thing came in my mind, it's like the threat model or, the kind of threats that were available at the time was completely different from what we have today. Yeah. So at the time, probably they were more worried about, the whatever structural failure or, operation, mechanical, all sorts of things. But they were probably absolutely not thinking about cybersecurity and let's say hacking. And so today has dramatically changed. And I think in the last few years, we have a lot of examples with has happened. So that's why probably cybersecurity, the buzzword now is popping up. So the threat model and the scenario has changed a lot. And mostly probably because it's so affordable to build, let's say, a radio. At the end, to try to hack a satellite, what you need, let's say, a radio, if you talk about a radio link, and an antenna. And then you can try to, send a signal, receive a signal, and you try to fiddle with it and try to hack it. And today, well, it's probably, what is, €100 what you need, in equipment. And there is many examples, I think, also. There was a lot of research done and published. There was very good research, probably, James Pavour from United Kingdom, who has done releasing a lot of interesting research where he was actually himself, doing his PhD. He was analyzing and taking a simple radio, again, software-defined radio. So you need a little bit of engineering and software skills. Then he set it up, and then he start to listen at, what's coming above your head. So which satellites are coming, and he was basically intersecting all sorts of signal, and then he figured it out. I don't know, there were communication of some ships. They are, let's say, in open sea, communicating with the ground, and then he could actually read messages because nothing was encrypted. So there was, private message of the seaman to the wife or all sorts of things. So this make you actually understand that now that things have changed dramatically. So we rely now much more in this kind of services, as we saw during the conference, software defined. And then when it comes of the level of, you ask numbers, it was mentioned, you strive for the 100%, it doesn't exist. Probably you can say you don't have any, failure because probably no one tried even to hack it. Most of the time, the situation is like, you hope you go under the radar, so to say, so no one is actually looking at you, no one is trying to hack your system because that's what normally, many actually missions or many, CubeSat are launched saying, well, okay, I don't have anything to lose, so no one try even to hack it, and at the end, the level you can accept is based on the value you give to your asset. So if you have an important constellation of telecommunication satellite and you are selling, let's say, communication services, Starlink or something, then definitely your level is very, very high because you are asking people, money to get the service, and if your service is disrupted, then of course the customer will complain. But if you are sending a CubeSat, to capture some picture and maybe do some research, then your level is definitely very different. It depends. But 100% definitely is, let's say, unavailable, I would say.
Yeah, very interesting angles. Actually, I was looking for one another. That would be that, in my opinion, with downstream, the percentage should be like this, and with the upstream, it should be this. Would you like to add, or it's fine already?
Well, if I can just... It's again, it applies. Depends on what you need exactly. So if you are selling your downstream services, probably then it will be hard. But it's interesting to many actually talk a lot about this Earth observation and downstreams. I'm selling images, and very few talk about the upstreams actually. And if you think, and probably we will touch, but the upstream, the very delicate part is in the upstream, you're actually sending commands to your satellite to move, change orbit, or correct the orbit, which is a very hot topic, to avoid collidance and or maybe to tell to the satellite, okay, your time is up, please come down. You know, it's and so it's very crucial actually to protect this kind of messages and commands you are sending to satellites. So you need to probably there. It could be that your need for the the percentage of security should be probably very, very high, because you can easily disrupt the service if you change trajectory of if you make your satellite coming down. So I would say there it's maybe very very high compared even to the downstream. In downstream you might maybe allow to have some glitch, miss some picture or get corrupted some data, but you can't fail to protect your upstreams in a way that it could disrupt entirely your satellite forever. Let's say.
Any additional ideas?
No, just a question on the point that you made for, it's more critical for the upstream, definitely, to protect the infrastructure, but your infrastructure is there to provide the services downstream. So in the end, like, I would say equally important to protect both way communications.
So don't bite in the tail, basically.
Right, exactly. So,
Kaarel, you have the third say in this.
Yeah, maybe to say just this, cybersecurity does not get the attention that it really needs, to be honest.
Okay.
So cybersecurity, should be, well, as a cybersecurity professional, this is our view. There are definitely other views and other opinions on this. That cybersecurity should be part of the foundation of any design, not a bolted-on feature, which it usually is, because it usually. The perception is that it's not my problem until it becomes my problem.
Very good.
That's my view. My view in it.
Very good. Let's go further with a perhaps bit more practical view of cybersecurity, but in some sense it is also really intellectual. I would like to point out three basic key ingredients in cybersecurity, and which are always where there is a data involved. And these are confidentiality, integrity, and availability of data. So what do these terms mean? Confidentiality is that the right people, the people who are authorized to have the access to the data, have the access. Integrity is that we know for sure that data is as it should be. No one hasn't tampered with it. And availability is meaning that people who need to have access to it have it. So as we are all speaking of cybersecurity, but it is like space and cyber, and it is really mystique in every way. So let's try to find examples of confidentiality, integrity, and availability from space domain. And if each and everyone could come up with one example and describe it a bit, then that would be perfect. Everyone can take something home.
Well, if I can, I have one, because this is one for me very, very hot topic. I'm very passionate. So
all right, keep it coming.
When you say so, the C for me, it's which, let's say, you can translate part of this C is the need for authentication. So ensuring the right person is the one receiving the data or is able to access the data. And now, because you mentioned space, so let's say a typical example and why this is a problem also in space, I touched briefly exactly before, when we say the critical aspect also is to ensure that, let's say, you send the commands to a satellite and the satellite should recognize you. So this is the first thing, is the satellite should be able to identify you as an operator. Let's say you send a command, we mentioned before, let's say a command to turn right, to make it simple. and change the orbit. So the satellite should be able to authenticate yourself, and authentication now is based on cryptography. So you have, we use cryptographic function to allow this kind of authentication. A parallel on Earth, we have passport. So if you pass custom, you provide your passport, and through that passport you are identified, and eventually you pass. So the satellite should basically use a similar mechanism. By the way, we use this on Earth, right? Every time you navigate on internet, and there is something going on which use digital certificate verification. So this is technology we know very well on Earth, but in space is still a challenge. It's not absolutely mainstream. And so the need to authenticate bidirectionally. So the satellite needs to know who you are. Once it knows, okay, you are the authorized operator to send commands, then the satellite can actually execute that command. And today the technology is available, but in space it's still a problem to implement, or at least it's like you mentioned. It's probably one of the last problem to be solved, because if it doesn't touch me, I don't do anything. And I think today, until there will be, I'm not wishing for it, but until there will be major cybersecurity accident involving satellite, yes, we had Viasat and others, but like human being, you don't react until something is touching you deeply. So until there will be some major cybersecurity breach and accident, probably there will be no reaction. Just to complete, so you authenticate the user or the operator, but the other way around is also important. Imagine how valuable. I think there are a lot of services, Earth observation services involved in, for example, selling these SAR images, right? So there are satellites which snap very nice detailed picture using this SAR technology, and they can give you a glimpse, or let's say very good view of what happens on the ground. And since we have more and more satellite rotating, now this coverage starts to be very, very thorough, and you might have more paths every day. So that means that with this kind of services, you'll actually see people, objects moving on the ground very easily. It can be even tank or cars or anything. So those data are now, I would say, mainstream. We have a lot of company making a lot of money selling this kind of services. Now, what's the point is, make sure that, let's say, the customer you are selling your picture will be the only one able to access this data. Because if you look the entire loop, from a satellite snapping a picture, elaboration on the satellite, sending to the ground station, so the antenna receiving, elaborating, then sending to maybe some other intermediate until it reached the end user which paid for that picture. So there are a lot of steps in the middle. What you want to do is protect end-to-end, ideally. So you could, use some encryption on the satellite, and then authenticate the end user, and only him will be able to receive this data.
Okay, so
this
you
is
covered
definitely
confidentiality and the availability.
Yeah, it's available. Yeah, well, I don't want to continue because there are many aspects, but we can touch also the other.
Other examples, please.
Yeah, I would take the I part, so the integrity part, which is core of our business. We work on solutions that support or enable network asset monitoring and monitoring and vulnerability detection. And this really links to the space assets as well. So the key element of the security regarding the integrity is to have a proper overview of assets, of your space assets, and there is always the lack of reference points to understand what's actually happening and going on with my devices or my space assets, my data, my commands, and I really need to make sure that they haven't been tampered with, either with the commands. Already this has been this very very important topic that can be handled with integrity solutions, also with confidentiality solutions, but also understanding what's the status of my assets. So what are they doing? Are they doing the right things? Can I be sure that they are doing the things that I want them to do? So integrity solutions would support the overview of that.
Very good.
In my view.
Very good. Srinivas, what is the closest to your heart out of the
Let's say the confidentiality, or that's one which has to be maintained, and the availability of the data. So these two are like really important, because I believe the smart people who are working on the cybersecurity topic, they have found the solution to make the data, ensure the integrity of this data to almost certain extent, which is desired by the application features nowadays. So the confidentiality part is really critical. So here, like, someone has to come up with a bit more innovative solution to say, like, which is kind of a hybrid solution, so that like you model-based blockchain or something like that. I'm not sure. I'm just tossing up the buzzwords here. So it's still has the integrity of the data, but at the same time, it does not disclose any of the aspects of it. And to verify this is also very tricky in the case of space traffic management. And this is one of the blocking points for making data available to all the players in the space traffic management. China does not share any information with European entities, and US does not want to share any information with Russia, and Russia does not want to share with Europe, and Europe does not want to share with some other entity. So, you know, and there is a lack of this information, but the precursor of this problem is basically that, like, the technology which could be made it confidential without sacrificing the integrity of the data. So that would be the short example. But also, like how Paul mentioned in the last discussion, that like one of the solutions to have a decentralized system, right? And to have that one, I think all these three parameters that you have identified are very crucial in enabling a kind of decentralized space traffic management system as well. Mm-hmm. Yeah. Mm-hmm.
All right, great, thank you. We have described now the situations where the risk is there, but what are the biggest inhibitors so that the outcome would be more secure, and who has the key role in it? So who should initiate changes? Yeah. As a short answer, because I have one burning question more.
I can start. From my point of view, for, let's say, space application, one of the obstacles is the lack of updated standards, I would say. So I name, all the issue related to the sea. So as I mentioned, this kind of technology exists on Earth. We are using it. We use digital certificate. We are able to authenticate, all the endpoints. But in space, what I see, it's like many companies, they kind of do their own recipe. So they are, because there is a lack of standard telling, you should do this way. At least the standard, they don't cover all the aspects. For example, digital, certificate is something missing in them.
And who should be initiator?
Yeah, that's probably, I would say, the easiest way. Okay, it's, well, industries in a way, that was always happen, right? You find there is a need. You see that there is a problem, and probably company, the smallest one, maybe startup, are faster to react, because that's one of the advantage of being a startup. You are just faster to work, and so the initiation, it's already happening, basically. So I already, you can hear around. So different company do different way, because they say, we have a problem, it needs to be solved. So what we can do, we just work on it. But then eventually, I'm a big advocate as well for standards, because especially in cybersecurity, you can't do things on your own and hoping everything will be fine. So it should be a collaboration. There should be a lot of work done, research done all together. And at the end, ultimately, there will be, again, standards that dictate how things should be done. And today, we are a bit behind in that. Right.
So collaboration is the key word. Your inputs?
Yeah, I wouldn't say that there is a driving force behind inhibiting the take-up of cybersecurity means or solutions. But as I come to my previous point, is that if there is no problem at hand, then it's not handled right away. So if it's not my problem, it's not my problem. But I think, well, yes, collaboration. Definitely, we need collaboration on this topic. Small players, big players, technology enablers, and so on. But certainly, ESA has a strong key to play here, because, well, they are let's say, they have paved the way of European space industry, being the driving force of the European space industry, and probably they would need to be partly at least leading this.
All right, great. Srinivas.
I can only concur with what Stefano and Kaarel mentioned earlier, so confidentiality and the institutional players taking the lead on this one. Together with that one, also, it has to be from the top down, so the enforcement has to happen at the national or international regulation authorities and the policymakers level. So
very good, thank you. And as a pulled question to the end, I expect only a strong yes or strong no. And the question is, so, yesterday there was a discussion whether post-mortem cybersecurity incidents analysis should be a thing, a real thing within the European space ecosystem. Yes or no, please?
I would say it's already there. This is the way.
Yes or no?
We know accidents.
Yes.
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 These were strong guesses, or?
Yes, very strong.
Like really
I believe
strong?
that it's the availability and the integrity and all the other factors plays the role, whether it could happen or not. But whether it should be the part of the ecosystem, yes, definitely yes.
The yes is strong, but there are caveats. So probably nobody wants to reveal that, I really made a mess.
All right.
But when they happen, it's because someone has done the research and published. This is why I say it's already there, because this is the only way when we know that those accident happens. But yeah.
All right. Thank you very much from my side. Thank you.
Thank you.
Thank you to the audience.